We also have a Python example for this modulation principles. So in the following example, we take the signal from a microphone and we'll modulate it with a 500 Hertz sine function. So we're multiplying it with a 500 Hertz function. Here we are going to use PyAudio and IPyWidgets to control. So we define our parameters. So we are using 32 kilohertz as sampling rate. Here is the function that's going to be run on the separate thread. Then we are reading from the audio input stream into the data with the block length defined by chunk. We are converting this stream of bytes to a list of short integers. Here we are computing this block array of the sine samples with 500 Hertz, and then we're multiplying our samples. So this is where the modulation takes part. Then we convert from integers back to the stream of data, and we write the stream. Here is just the GUI. So we have a start and a stop button. So let's run and see what happens.
Hello, test. I'm testing the Mickey Mouse voice. This is the modulation taking place. Hey.
So we see that the sound and the voice sound higher in pitch, something like a Mickey Mouse voice, and this is the result of the frequency shift. So the conclusion is that we can shift our ideal filter in the frequency domain by multiplying the ideal or already windowed impulse response with a modulation function defined like this, for example, where P can be some phase delay. And this is illustrated in the following picture. So we have our low-pass original spectrum, and then after modulation with a frequency omega null, and we have copies of the original spectrum where the center frequency now is our modulation omega null.